While the shuttle program basked in numerous triumphs, it remains mired in tragedy. 2 years after McCandless's spacewalk, disaster befell Challenger, 73 seconds into launch.
Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
A rubber O-ring in one of the solid rocket boosters failed.
And that allowed hot gases to cut through a strut, which was holding on the big external orange fuel tank.
Challenger, go with throttle up.
The entire space shuttle and tank ended up self-destructing.
Flight controllers here looking very carefully at the situation.
The shuttle program endured a second disaster 17 years later in 2003. During Columbia's launch, a piece of foam insulation broke off from an external fuel tank and struck the orbiter's left wing. The heat shield was compromised.
It didn't prevent the space shuttle from safely reaching orbit, but it was a very, very big problem for re-entering.
Yeah, you definitely don't want to be outside now.
As Columbia descended into the thicker atmosphere, hot gas penetrated the craft, causing the wing to tear from the shuttle. Columbia disintegrated, killing the 7 crew.
Space is hard, we say in this industry, and the astronauts paid the ultimate sacrifice. The reverse of that, of course, is the fact that so many missions came after. We learned from those mistakes, we continued to explore, that mission went on. And so I think that that's the best example of what we do as human beings.
While NASA persevered through both tragedies, the shuttle program never fulfilled its initial promise.
It was a marvelous instrument. It was a fantastic vehicle. It just cost too much to keep reusing.
When first proposed, the cost of a single launch was estimated to be as low as $22 million US. In the end, the average cost was $450 million.
For all that, the space shuttle could hold its own against any number of the other marvels of the space era.
Space Shuttle Atlantis completed the program's final flight in 2011.
Having fired the imagination of a generation, a ship like no other, its place in history secured, the Space Shuttle pulls into port for the last time, its voyage at an end.
As the 20th century came to a close, construction was underway to facilitate a new age of space cooperation.
302, BP44, 871, 6290.
Astronauts aboard the Space Shuttle Endeavour delivered and connected a station module called Unity to the Russian module Zarya.
Houston Endeavour, we have capture of Zarya.
The International Space Station was born, but it was far from complete.
It took a decade to actually create the full International Space Station, but once the first 2 or 3 components had gone into space, the first solar panels, the first modules, the first power systems, you could put a crew on board. You could start to do the science.
An international community would be invited in. This would demonstrate that collaboration and cooperation was the way space was going to go in the future.
Since November of 2000, humanity has maintained a presence in low Earth orbit, aboard the world's greatest laboratory.
It really opened up space to the world in a way that had never been accomplished before. It just made our ambitions greater.
Following the space shuttle's decommission, the Russian Soyuz provided the primary access to the ISS.
The fact that Soyuz has been the workhorse of ferrying both astronauts and cosmonauts up to the International Space Station since the end of the Space Shuttle program in 2011 speaks volumes for the effectiveness and how well designed it was, how well it fits the requirements for a space taxi.
And the hatches between the Soyuz spacecraft and the International Space Station opening. Could you imagine telling the very first people in NASA in 1950s, in 50 years, you're going to need the Russians to get into space? I think that would be a mind-boggling statement to tell someone at that time.
On May 30th, 2020, astronauts once again launched from American shores. This time aboard a capsule and rocket designed by a private company, SpaceX.
Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX.
Now we're moving into this new era of the commercialization of space, the space entrepreneurs. And so all of these companies and industries are looking at new ways to be able to use the facilities of the space station. That commercialization, of course, will help to fund its future.
The International Space Station has become part of this modern-day movement, or progression really, to democratize space. And what that means is it just gives a more level playing field style of access to space for just about anyone.
The International Space Station is the only place where we can learn what will be required when humanity chooses to venture beyond Earth's orbit.
If, as a race, we are to explore the universe, we need to have the experience. We need to have an understanding of how to handle those extreme environments.
So we're now using the International Space Station as that test ground to see what the effects long-term will be of humans in space, not only the lack of gravity, additional radiation, how do you grow food along the way, how do you survive in a closed environment that has to work perfectly for those future journeys.
The story of the International Space Station will soon come to a close, but its place in the history books will endure as a testament to what a united humanity can achieve. From seeds of rivalry, we have opened a gateway to the cosmos.
In space exploration, we find our greatest challenges and we rise to that challenge.
As we ventured into the unknown, humankind has grasped the impossible.
One of the huge benefits of scientific endeavour is its capacity to bring people together in order to achieve something that has long-lasting impact for the betterment of our society.
Establishing a foothold in orbit, we craft a better world.
It's a keystone for humanity to come together and do something for the benefit of us as a whole.
Our fascination with the moon dates back to time immemorial.
The moon is that perfect distance. So close you can almost touch and be inspired to travel, but so far you got to work real hard to do it.
Earth's companion, long before life existed on our planet.
And you could look up and always see it and always know it's there. So it's always been this fascination of wonder and awe and looking at, and I guess wanting to reach out.
Scientists hypothesize that our moon formed over 4.5 billion years ago, the product of a collision with the protoplanet Theia.
Theia is thought to have hit the Earth and caused the outer layers of the Earth to be shed to form a cloud of debris, which eventually coalesced into the moon.
Over time, our natural satellites settled into orbit, a single side frozen in view, beckoning. Humanity's lunar dream came into focus after the Soviets launched the first Earth-orbiting satellite in 1957. The USSR followed the achievement, placing the first human in space 4 years later.
If you put yourself back in those times, thinking about the incremental steps, okay, we've put somebody in orbit. What's next? Well, let's send somebody to the moon.
The moon became the ultimate prize in the race to dominate space between the US and USSR. Robotic probes would venture first, paving the path for humans. The Soviets' early successes were led by Sergei Korolev, who was known in the West only as the chief designer. Reaching Earth's orbit was one thing. but escaping it would be an even greater challenge.
To simply break the bonds of Earth's gravity is an incredible technical challenge. There needed to be huge developments to get off the surface of the Earth.
In 1959, the USSR prepared the first robotic emissary to the Moon, Mekta, also known as Luna 1.
The Earth is a very, very large, heavy object, and therefore to escape its gravitational pull requires a lot of energy.
The first object to escape Earth's orbit, Luna 1 needed to exceed a speed of 11.2 kilometers per second, 33 times the speed of sound. Luna 1 missed its target by nearly 6,000 kilometers. However, there was a silver lining. The probe continued its journey, eventually becoming the first spacecraft to directly orbit the Sun. America's first step toward the Moon began with the Pioneer program, a fleet of probes built to explore the solar system. Pioneer 4 was the first to successfully launch in March 1959.
Midnight is to be the witching hour, and it's a tense and dramatic scene as the rocket is fueled for its fantastic flight.
Unfortunately, its second stage rocket overperformed, and Pioneer 4 met the same fate as Luna 1, becoming the first US spacecraft in solar orbit. The Soviets successfully reached the Moon before the end of the decade, but it wasn't a soft landing. The debris of Luna 2 was strewn across the cratered surface.
Luna 2 was the first object to actually impact the surface of the Moon.
Western observers monitored Lunix 2 radios to the very moment of impact, dead on target.
It was a real engineering feat to get something from the Earth to go 250,000 miles across space and to hit this very small rock.
It carried with it little medallions that were inscribed with the Soviet coat of arms. So while it was a piece of technology meant to demonstrate the USSR's success, it was also meant to implant the Moon with the symbols of communist ideology.
It would be several years before the first controlled landing. The Soviets' Luna 9 was designed to impact the Moon at 22 kilometers per hour, cushioned by a landing bag.
It must have been just an amazing sort of tick-the-box kind of moment to show the world that, yes, we can actually have a controlled descent onto the lunar surface, which is something that's mandatory to land humans there.
Luna 9 commenced its secretive photographic survey on February 3, 1966. However, the transmissions were intercepted by the Jodrell Bank Observatory, and an English newspaper was able to publish its pictures to the world.
Now, the vehicle didn't last very long, but it did show the capability of the Soviet Union at the time to be able to get a spacecraft down to the surface and safely.
With the first probe sitting safely on another celestial body, the race was on to explore the Moon in preparation for humans.
Even with the best telescopes on the Earth, we're seeing areas with not very high resolution. We needed to see the smaller scale. We needed to look at the terrain. The scientists wanted to understand where were the places, if we were going to send robots and humans to the Moon, where do you want to actually explore?
Surveyor 1 was fit and ready. It will not be seen again until it sends a picture of itself from the Moon.
The primary goal of NASA's Surveyor program was to demonstrate the feasibility of soft landings on the Moon.
3, 2, 1, we have ignition. We have liftoff.
People didn't know that the lunar soil would be robust enough to support the weight of a spacecraft, even with only 1/6 of the Earth's gravity.
The first of 7 surveyors touched down in the Ocean of Storms on June 2nd, 1966. It was soon transmitting a wealth of data.
The surveyors were essentially designed to look at the environment of the moon, to measure things like the flux of micrometeorites, these are tiny particles of space dust that impact the moon, to look at the radiation reaching the moon from the sun, to look at the way materials behave when you've got this vast range of temperatures.
The surveyor fleet could only remain planted in place. To explore the entirety of the moon with enough detail, NASA needed satellites in lunar orbit.
A series of 5 probes were sent up to photograph almost the entire lunar surface, 99% in fact.
Lunar Orbiter was designed to circle the moon with a pair of cameras to photograph large areas of the Apollo landing zone and give good close-up pictures of many possible landing sites.
Using those photographs, engineers and scientists were able to pinpoint the areas that you could land that would give you the best chance of success.
The moon was revealed to be almost fractal in its nature of crater upon crater. The closer we looked, the more hazardous it became. Boulders appeared out of nowhere as you zoomed ever closer. It revealed a world that would be challenging to land on.
Humanity's robotic emigrants revealed more about our natural satellite than ever before. But most importantly, they selected the perfect spot for humanity's first small steps.
Those first insights showed us that this was a world more fantastic than we could have dared to hope and worthy of further exploration.
On September 12, 1962, President John F. Kennedy challenged America to place a man on the moon by the end of the decade.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
There were so many hurdles that needed to be traversed in less than 10 years, and there was absolutely no way the US was ready to be able to do that.
NASA initiated the Gemini program in 1962 to serve as a bridge between its fledgling Mercury spaceflight program and the Apollo missions to the moon.
The US approach to getting to the moon was highly orchestrated in steps that were manageable, and without one happening, the other would not happen.
With the induction of 9 new astronauts, Gemini provided America's spacefarers with much-needed experience.
Its goals: test the skills and endurance of the astronauts and practice the rendezvous and docking procedures for the moon voyage.
During Mercury, the astronauts remained inside the spacecraft. Gemini was about tinkering with the different technologies and the different challenges and maneuvers of being in space outside the spacecraft.
Ed White became the first American to venture outside his capsule for 21 minutes, navigating space with a handheld maneuvering unit.
A new term was born, EVA, extravehicular activity.
During the 12th and final mission, Edwin Buzz Aldrin performed 3 spacewalks, totaling 5.5 hours. Gemini also provided NASA's engineers time to design and build the vehicle capable of delivering 3 humans to the moon, the Saturn V.
The Saturn V is a marvel. It is the most staggeringly complex machine that has ever been attempted. The fact that this worked never ceases to amaze me.
To get to the moon, you need a rocket, this rocket, the biggest yet built, Saturn V.
You can't spend months getting to the moon, you have to get there in a few days. So that means you need enough energy to get you fast enough to get to the moon. Now, as you build a big enough rocket, you add more fuel, which adds more weight. That gravity literally holds you back. So you have this battle between weight and speed that you're trying to fight over to get you as fast as possible to the moon.
The Saturn V's development was led by Wernher von Braun, a German rocket scientist snatched up by the US government at the end of World War II. Von Braun spent the following decades building upon the rocket technology he had once developed for death and destruction. Behind the Iron Curtain, the Soviet government made plans for a circumlunar mission to take place in 1967, the 50th anniversary of the October Revolution. However, plans came to an abrupt end when the chief designer, Sergei Korolev, passed away. America had to contend with its own major setback in January 1967. 1 month before their scheduled launch, Apollo 1 astronauts Gus Grissom, Roger Chaffee, and Ed White, the first American to perform a spacewalk, conducted a series of tests on the capsule's electrical systems.
A number of problems had not been thought of. For example, there were many flammable materials inside the command module, and indeed even in their spacesuits.
And the atmosphere inside was pressurized with pure oxygen. You can breathe pure oxygen, but it's actually a real catalyst for fire and explosives.
Over 3 hours after the men had been sealed inside the capsule, a voltage surge was recorded. 10 seconds later, the crew reported fire.
Hey! Oh, there's fire in the cockpit!
And so this material suddenly went up in flames. The oxygen fed the fire to absolute inferno, and tragically, the door could not be opened because of the air pressure inside.
The Apollo capsule had been designed with an inward opening hatch. The internal air pressure, exacerbated by the fire, pushed outward, sealing the astronauts inside. All 3 astronauts perished in America's race to the moon.
When you are doing something that visionary, that transformative, that ambitious, it is hard to have 0 casualties in some ways.
Though a terrible tragedy, the Apollo 1 fire became a turning point in the American space program.
It actually galvanized the astronaut corps, it galvanized the engineering teams, the scientists, to get in there, look at the problems, solve them, redesign, rebuild the spacecraft, make it safe for the human travelers.
Vulnerable wires were coated and fire safety measures implemented throughout the cabin.
They then redesigned the door to one where you could exit very quickly in the event of an emergency. They also changed the air mixture inside, so it was no longer pure oxygen, it was a mixture of oxygen and nitrogen.
And less than 18 months after that tragic fire, we were sending the first humans to the moon.
To ensure the safety of their astronauts, the next 3 Apollo launches were uncrewed. Then, in October 1968, humans finally returned to low Earth orbit, with Apollo 1's backup crew taking their place in the history books.
Liftoff of the 1,300,000 pound vehicle was perfect. The first manned flight of Apollo commenced what was to become known as a textbook flight.
Apollo 7 was the first crewed mission of the Apollo program. So it was really important to make sure that the living environments were habitable, that they were safe for 3 astronauts to spend more than a week living there together.
On board, command pilot Schirra and pilots Cunningham and Isley demonstrated that men could live and work in space with increased comfort and efficiency.
Apollo 7 also demonstrated that the command module could safely re-enter the atmosphere,
which is one of the most dangerous parts of such a mission. So it was a real stepping stone to the moon.
The flight of Apollo 7 lasted 10 days and added immeasurably to the confidence level of our space program.
Meanwhile, in the USSR, the lunar dream was getting closer. In September 1968, they sent the very first animals, including 2 tortoises, around the moon aboard Zond 5. After 1 week traversing the heavens, they returned safely to Earth. The Soviets had bridged the Gulf to the moon. Now the Americans would cross aboard Apollo 8.
Apollo 8 was the most important human space mission. 11 was easy compared to 8.
This mission plan was to circle the far side of the moon, enter orbit around our satellite, and return. After a full Earth orbit, the third stage of the Saturn V reignited, setting a course for the moon. 2 days later, Apollo 8's crew became the first humans to reach a distance where the Earth no longer held the strongest gravitational pull. But in order to be captured by the moon's gravity, their trajectory needed to be perfect.
Meters off, you just sailed out into the emptiness of space and they would have never had a way of coming home.
The capsule slowed into lunar orbit.
Once you go around the moon, the far side, you cannot communicate with Earth. The moon is literally blocking you. So if something goes wrong, you are literally alone in the void of space.
Mission Control would have to wait 32 agonizing minutes for Apollo 8 to reappear.
There was a lot of things that could have gone wrong. People would have been seeing these astronauts sail away into space, slowly dying. It would have killed human space exploration.
Not only did Apollo 8 successfully circumnavigate the moon, it did so 10 times.
The mission of Apollo 8 was a really bold move by the United States.
They were first human beings from the planet Earth visiting another world. They became satellites of the moon.
It gave human beings the very first glimpse of the Earth rising above the surface of the moon.
All right, you're looking at yourselves as seen from 180,000 miles out in space.
Seeing our little fragile blue marble in the vast darkness of space was the catalyst for the modern environmental movement.
It was a beautiful experience, I think, for all of humanity.
Apollo 8 demonstrated that the US could successfully deliver humans into lunar orbit, but a dress rehearsal was required before the first footprint. During Apollo 10, 2 astronauts boarded the lunar lander and practiced the descent towards the moon's surface, but they weren't allowed to land.
Now, there was speculation at the time that they wanted to make sure the astronauts weren't tempted to land on the surface of the moon. So the story, which is in some ways urban myth and some areas true, is that they didn't give them enough fuel on board the spacecraft, so they weren't tempted to make that final part of the descent.
The fact that NASA didn't give Apollo 10 enough fuel to actually land and then safely take off suggests that they were aware of the allure of that first landing. Astronauts are near superhuman, but they're still human, so they might have been tempted. Those kind of missions paved the way for Apollo 11.
Meanwhile, the USSR was modifying their counterpart to the Saturn V to deliver humans to the moon. But on July 3rd, 1969, an explosion destroyed the rocket's launch pad. Soviet lunar exploration was relegated to their fleet of probes. For the US, the day was approaching. Years of technical development, engineering breakthroughs, and rigorous training, all built to a single moment. On July 16th, Neil Armstrong, Buzz Aldrin, and Michael Collins boarded Apollo 11. Breaking free from the Saturn V, the Command Module Columbia and Lunar Module Eagle continued toward the moon.
Once the Apollo crews reached orbit around the moon, they then had the final challenge of getting onto the moon's surface.
While Collins remained in orbit aboard Columbia, the Eagle descended to the moon.
Roger, copy.
The astronauts were using an automated system on board. The onboard radar was ticking off the descent rate.
Until the computer started spewing out all these error messages.
Reading on the 1202 program alarm.
Those computers were actually heading the spacecraft towards a large boulder field. So Armstrong took over the controls. He had to fire the engines for longer periods of time. Fuel was starting to be used up at a much higher rate than we predicted.
60 seconds.
You can hear Houston Mission Control counting out how many seconds of fuel they've got left.
30 seconds.
It came down to actually the last 16 seconds of fuel left.
Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
The astronauts were supposed to have a rest when they landed on the moon, but they really rebelled against that. They wanted to get out there. They wanted to get going.
Just 12 years after humanity breached the heavens with the first artificial satellite, we placed our feet upon an extraterrestrial world.
It's one small step for man, one giant leap for mankind.
Across the globe, people were able to witness the historic moment.
They set up a television camera, the first thing to be placed on the surface after the landing module. If you think of the most culturally significant object at the Apollo 11 landing site, it's probably that television camera because it recorded the images beamed to approximately 600 million people across the world.
As Armstrong and Aldrin experienced the lunar surface, Collins attended to maintenance aboard Columbia, whilst ensuring it had the proper trajectory for his colleagues' return. Continuously circling the moon, he lost contact with all humanity for 47 minutes on each of the 30 orbits.
That is the most isolated feeling that you can possibly have. But at the same time, I've heard that being the support line for colleagues walking on the moon is an incredibly satisfying and incredibly rewarding feeling.
America's mission extended beyond the first small step. Armstrong and Aldrin deployed retroreflectors and other scientific instruments to unlock the moon's secrets.
They wanted to find out, was the moon seismically active? And so they set up seismometers. Back here on Earth, they could even actually measure the footsteps of the astronauts as they bounced past the instrument. They also had to collect geological samples. So these astronauts, these pilots, had to also become scientists. Right at the end of the mission, they were told, you don't have enough rocks collected yet. So there was this frenzied few minutes just before they had to get back in the spacecraft. An astronaut, Armstrong, actually said, well, we've collected all the samples we can get. They might not be the best samples, but we have them. And we're still studying those rocks today.
As Armstrong and Aldrin completed their 2.5-hour spacewalk, the Soviets' Luna 15 was attempting to land. It had arrived in orbit 2 days earlier, with hopes of returning a soil sample to Earth before the Americans. But the landing had been delayed. As it descended to the surface, the Soviets lost contact forever. The space race was effectively over. Less than a day after the Eagle landed, it was time to depart.
President Kennedy said, we're going to get a man to the surface of the moon and return him safely to the Earth. That was the important part, getting them back home again.
After successfully reuniting with Columbia, the Apollo 11 crew returned to Earth. Splashing down in the Pacific Ocean, The USSR never came any closer to sending a citizen to the moon, but they persevered, developing machines for exploration.
Astronauts are good at making decisions and identifying various features and geology, but rovers are also very successful in exploring the moon because they allow us to travel further and to be more interactive with our exploration.
The Soviets' Lunokhod 1 was the first robotic rover to venture beyond Earth. It drove 10.5 kilometers over 321 Earth days, returned over 20,000 images, and performed experiments on 25 soil samples.
Because the moon has no atmosphere, all of the tracks are just laid out there for us to see. They're going to be preserved for possibly millennia.
Lunokhod carried a retroreflector, enabling scientists to measure the moon's distance from Earth. Timing the return of a laser pulse after bouncing off a retroreflector reveals how far it traveled. Along with similar Apollo experiments, these endeavors revealed that the moon is moving further away, on average 3.8 centimeters per year. Having achieved the coveted first step, NASA's later Apollo missions would place increasing focus on scientific endeavors. Apollo 12 carried the baton of an earlier explorer.
An opportunity was taken to put the spacecraft down near Surveyor 3, an earlier robotic mission during the Apollo preparations.
Surveyor 3 had spent 2.5 years on the moon.
Putting up with the huge range of temperatures, the rain of micrometeorites, bombardment of subatomic particles from the sun, and the ultraviolet radiation from the sun, all of that had been withstood for a long period of time.
Pieces of Surveyor 3 were brought back to Earth, where scientists gained insights into the lunar conditions.
What they discovered was that the landing of Apollo 12 at the edge of that crater had stirred up a lot of dust, and this had abraded the surfaces of the Surveyor camera. This is only the second Apollo mission, and what they were coming to learn was that lunar dust was going to be a big problem for surface operations.
The third crewed mission to the moon was 2 days from Earth when disaster struck. Nine minutes after ending a television interview, the crew heard a sharp bang.
One of their oxygen tanks ignited.
Houston, we've had a problem. Had a BP bus undervolt.
The command module lost all electricity, light, and water. 2 of the 3 fuel cells were dead. Precious oxygen was leaking into the darkness. With 15 minutes of power remaining, the crew evacuated into the Aquarius lunar module.
The module, which was intended to keep the astronauts alive on the moon for a couple of days, then had to be quickly repurposed to keep them alive on the way and on the way back for, I think, about 4 days. And so it was a mad scramble to get the crew back alive.
While the Aquarius had sufficient oxygen to sustain them, it lacked the ability to purge enough carbon dioxide. On the ground, a team of engineers rushed to design a mechanism out of spare parts that could purge the excess CO2.
And 13 Houston, we'd like you to isolate the repress package, please.
Despite never landing on the moon, the mission was not a complete failure. The third stage of their Saturn rocket was sent crashing to the lunar surface. Calibrating seismic detectors installed by Apollo 12.
Odyssey, Houston, we show you on the mains. It really looks great.
The next mission, Apollo 14, successfully landed in the Fra Mauro highlands. It was commanded by Alan Shepard.
Of course, Alan Shepard, the first American to actually go into space, got to walk on the surface of the moon on Apollo 14.
He carried with him a sample collection tool, which had been modified into a 6-iron.
Being the keen golfer, of course, he was a bit disappointed by his first shot, which sliced the ball, and then he took his next shot, steadied himself, he hit that ball. They asked him, "How did it go, Al?" And he said it went for miles and miles and miles.
The mission, however, was not restricted to lunar recreation. The crew discovered Big Bertha, a 4-billion-year-old 9-kilogram rock that likely came from Earth, the first terrestrial meteorite. For the first few missions, astronauts were restricted to local exploration, but both range and ambition increased come Apollo 15.
It was the first real in-depth science mission. And the astronauts had taken the challenge of doing the science very, very seriously.
The tower is clear. And we have a roll program. Roger.
Over 3 7-hour-long spacewalks, astronauts collected samples from 12 different locations, exploring the moon's volcanic history. To facilitate wider discovery, NASA engineered an ingenious transportation system in just 17 months, the Lunar Rover.
To design a rover in such a short amount of time, to have it operate so spectacularly, these are incredible achievements. The fact this thing even managed to make it to the moon alone is stunning, much less that it worked and looked so fun. And sometimes space exploration just has to be fun.
It's working, my friend. Beautiful.
They could go off on these longer journeys day after day, moving further afield, collecting geological samples from diverse regions.
The Apollo 15 astronauts traversed 12.5 kilometers in a single spacewalk.
And so the Lunar Rover really changed that ability to do that thing that we love to do, and that's explore.
The next mission, Apollo 16, touched down in the central lunar highlands, set apart from preceding landing sites. For years, scientists had believed that the region was a product of ancient volcanism. But nearly every rock Apollo 16 collected had not formed from volcanic activity. The supposed history of our moon continued to evolve. The geological discoveries continued, with greater focus during Apollo 17.
One of the crew was a geologist. For the first time, a scientist went up as a crew member.
Harrison Schmitt discovered tangible evidence that our moon once sustained a magnetic field.
He was able to bring back to Earth material and evidence for the geology community to really make some quite transformational discoveries about the moon's origin.
And he was traveling with Captain Gene Cernan, who was a military pilot. So they had very different backgrounds, very different experiences. But I remember Gene Cernan telling me that, in fact, he was a little bit converted as a geologist and found the rocks and the collection of rocks very exciting.
It turns out that that mission brought back more scientifically relevant material than the whole Apollo program itself.
Holy smoly! Why are we on a slope? You okay?
Man, that's rough country in there, isn't it?
After more than 3 days on the surface, it was time to depart.
We leave as we came, and God willing, as we shall return, with peace and hope for all mankind.
Apollo 17 returned to Earth, setting several records. The longest time humans spent on the moon, the longest extravehicular activity upon its surface, and the longest time in orbit. with waning political support and budget cuts, Apollo's future missions were cancelled.
It was such a huge investment. The public support for continuing that or expanding it was kind of dying down a little bit in the 70s.
Nonetheless, the Apollo program transformed our understanding of Earth's natural satellite.
I think some of the biggest success of the Apollo missions wasn't the human aspect. Yes, it was important, but they did so much for our understanding that we literally use today. If Apollo did not land on the moon and leave little metal reflector plates that we can bounce lasers off of back to the Earth, GPS doesn't happen the way it does.
The moon is part of our history because the Earth and moon probably have a common origin. So when we learn about the moon, we learn about our history here on planet Earth.
All these little scientific reasons were just an add-on to this human exploration. And that is, I think, the amazing feat of the Apollo is what it did for knowledge and not just inspiration.
It would take more than a race into the history books for humanity to return to the moon.
At least from the public's point of view, exploration for the sake of exploration was not sufficient. You had to have a mission that was not just about being first, but about something more. And this is where the robotic era begins.
14 years after the last lunar probe, Japan prepared to become the third nation to send a robotic traveler. Hiten was designed to test technology and orbital maneuvers for future exploration of the solar system. The Japanese probe was later steered into a temporary lunar orbit, where it measured cosmic dust. Within a decade, the moon had regained its status as the next frontier. A new kind of international competition was born.
And now many nations which are sort of at the beginnings of their space program, they're setting their sights on the moon as well.
It's about understanding what resources are there and perhaps being first to utilize those resources.
The European Space Agency's Smart 1 satellite was inserted into lunar orbit in 2004. Like Hiten, it demonstrated cutting-edge deep space technology. Employing a new propulsion system, Smart 1's ion thruster ejected subatomic particles, accelerating the spacecraft forward. In lunar orbit for 2 years, Smart 1's instruments mapped the surface, identifying the composition and distribution of minerals. Pushing the frontiers of lunar exploration further, China designed Yutu-2, the first rover to roam the moon's far side. On December 7, 2018, China launched Yutu aboard Chang'e 4.
And it's returning incredible science, going to places which are incredibly different from what we saw on the near side during the Apollo program.
Chang'e 4 delivered Yutu to the Aitken Basin,
which is actually one of the biggest impact basins in the whole solar system, a place where something very large hit the moon early in its history, probably within the first 10 million years of the moon's lifetime. Some of the rocks that have been found by Yutu-2 are actually a bit of a mystery because some of them seem to be quite young, much younger than you would expect to find in a place where an ancient impact had scattered the debris around.
Meanwhile, the US has been keeping a close eye on the moon from orbit since 2009.
Liftoff of the Atlas V rocket with LRO Albatross, America's first step in a lasting return to the moon.
A lot of the exploration of the moon that we're doing nowadays is actually from lunar orbit. We have very high resolution cameras. The moon has no atmosphere, no clouds. So we can actually really study it very well from orbit using radar, using infrared technology, and using high resolution images.
The Moon's longest operating companion, the Lunar Reconnaissance Orbiter, has collected more data than every extraterrestrial NASA mission combined. High-resolution maps identify points of interest for future missions.
We have returned to the Moon, and the boundaries of humanity's exploration explode when we decide to entrust exploration to robotic pioneers.
Launching in 2008, India's first lunar orbiter, Chandrayaan-1, carried 2 instruments based on Smart 1's design. The mission proved that the Moon was once completely molten and found the first evidence of water ice.
The Moon is a very dry place, but we do find water in very deep craters in shadows. And we also find it towards the poles, where it's cooler. So the Moon does have water, but it's really in icy form and it's hiding away.
The discovery of water on and near the lunar surface carries great implications for humanity's future beyond Earth.
Water on the Moon has changed the calculations for countries and companies alike. This game-changing discovery of these ice reserves has only really happened because of this robotic era of exploration.
The Moon is no longer a destination for just governments. Private industry seeks to see footprints in lunar soil once again.
We're in a very interesting period because everybody wants to go back to the Moon.
The new era of lunar exploration is to map out the water.
For humans to be able to go to the Moon on a frequent, reliable, sustainable way, access to water in situ is really important. Of course, we can take water with us. We do that to the space station. But the cost of doing that is huge.
The Moon will serve as a gateway to the solar system.
So that water ice can be used to make fuel. It can be used to sustain bases that might be built on the Moon for permanent occupation. And in the minds of a lot of people, this water ice can be used to make fuel to take people on to Mars.
The Moon becomes not just a stepping stone, it becomes a refueling and resupply station. And that has attracted the attention of nations and even companies.
National agencies and private industry have supported each other in development. From lunar landers to the rockets that will carry them.
We currently have a number of companies out there, commercial operators, with large, heavy launch vehicles.
We should really do our very best to become a multi-planet species, to extend consciousness beyond Earth, and we should do it now.
SpaceX has influenced spaceflight in an extraordinary way. In the old days, you threw away the launch vehicle because there was no way of salvaging it. But with the technology we have today, you can actually bring the launch vehicle back.
In addition to their current role, ferrying supplies to the International Space Station, SpaceX plans to return humans to the Moon within the decade.
It's a really exciting time, actually, that we're going back there. People like myself don't remember the moon landings. As we enter this new dawn of going to the Moon and eventually to Mars, I'm hoping we're going to get those moments again.
Bearing the name Artemis, the twin sister of Apollo, NASA's new human spaceflight program also has its sights set upon the Moon. The Orion capsule is designed to fit on top of the replacement for the Saturn V, the Space Launch System.
In the same way as Apollo had its stages of increasing sophistication of the mission, Artemis will see this return to the Moon and then beyond. It is a staged approach of getting ultimately to Mars.
And liftoff at dawn, the dawn of Orion.
Orion blasted off for her maiden test flight in 2014, reaching an altitude of 5,800 kilometers and orbiting the Earth for about 4.5 hours. a lunar colony may soon be on the horizon, be it as a permanent workstation or as a stepping stone to further worlds.
One of the aims of going back to the moon is to build some kind of permanent installation or base there for scientific investigation. But for many people, the whole purpose of going back to the moon is to mine all of the water ice at the poles, to use it for fuel, and make the journey to Mars just that bit shorter and safer.
It's going to be incredibly challenging to establish a human presence on the moon. It's a really bad environment to live in. There's no air. There's no magnetic field, which helps protect us from the dangerous radiation from space. It's close to the Earth, so we can deliver stuff, but keeping astronauts safe from meteorites and radiation and all those sorts of things is going to be very difficult.
The moon symbolises a number of things. In the same way the International Space Station brought many nations together, we are going to the moon to continue to learn about that cooperation, to build a scientific base there. All of these sorts of things are an example of the way that we can live and work better together on our own planet and harness the resources that space could bring and the benefits that come from doing that exploration, pushing the bounds of technology and what's possible.
The lunar dream has long been calling.
As a species, humans are absolutely fascinated by the unknown. Nowhere represents the unknown more than outer space.
Exploring Earth's companion, we understand our past, our planet, ourselves.
It's kind of in here. It's kind of human curiosity and human spirit.
Humanity's lunar achievements are just the first steps.
We're just doing what we've always done. These will take us off on journeys to Mars, to the moons of Jupiter and Saturn, and then even one day to the nearest stars.
4.6 billion years ago, our solar system was merely a giant cloud of gas and sprinkles of dust formed by ancient stars. But under the power of gravity, that cloud started collapsing, spinning ever faster and flattening into a disk.
Solar systems are pretty much always flat disks because when things rotate in space, they tend to flatten out.
A dense sphere of gas collected in the center. At its core, under the intense heat and pressure, hydrogen began undergoing a form of transmutation. Nuclear fusion, releasing an explosion of energy that continues to this day. The sun was born. In this new solar system, small grains of dust began sticking together. Over 100 million years, a few grew massive enough that their own gravity crushed them into spheres.
The planets actually were just leftovers from the sun's formation. And slowly over time, they accumulated more and more material from the disk around the sun.
Our star's radiation blew away lighter gases like hydrogen and helium from the inner system. Ice was unable to form, and 4 rocky planets arose: Mercury, Venus, Earth, and Mars.
We talk about the terrestrial planets. These are the inner worlds, the rocky bodies.
While all started out with a similar evolutionary process, each reached a unique fate.
If you learn more about these terrestrial planets, you will learn more about our own history. And fundamentally, space exploration is about learning about ourselves.
The brightest planet in Earth's sky, Venus is our immediate neighbor in the solar system, at the closest possible distance of 38 million kilometers. The planet has shaped our understanding of our place amongst the universe. In the 1600s, Galileo Galilei observed Venus's phases, helping to confirm the Copernican notion that the planets orbited the sun instead of the Earth. Humanity's comprehension of the solar system expanded over the centuries, but Venus's opaque cloud tops stirred speculation that habitable swamps or even oceans awaited below. Answers seemed in reach, with development of the first robotic visitor to another planet. But any craft venturing beyond Earth's protective bubble would endure the dangers of interplanetary space.
A probe in space can be subjected to conditions which are far beyond anything we see on Earth. We're quite lucky in that Earth's atmosphere protects us from extreme temperatures or radiation from the sun.
The closer you get to the sun, the more radiation that you have. When there's a solar flare, if the sun does a bit of a hiccup, you can get really strong, powerful streams of charged particles that can actually knock out a spacecraft's electronics.
Designing probes for the space environment requires careful consideration of radiation, heat, pressure, and also temperature changes, because it's very easy to, within the life of a mission, experience very high shifts in temperature.
In the early 1960s, NASA began developing spacecraft to explore the solar system. The Mariner program consisted of 10 probes, launched over a decade, destined for the terrestrial planets.
Destruct command. Destruct command.
After Mariner 1 failed just 5 minutes after launch, hopes turned to its successor as our first emissary to Venus.
Mariner 2, a sophisticated unmanned spacecraft with orders to gather data on the planet Venus.
The second Mariner blasted off from Cape Canaveral on August 27, 1962. However, piloting a craft toward the center of our solar system came with a special challenge.
It's actually very difficult to get to the inner planets. A probe would gain so much kinetic energy. You need to be able to slow them down, or they just whiz right past.
So a spacecraft leaving the Earth's surface, relative to the Sun, it has very, very high velocity, and it's got to lose that velocity to be able to reach Venus.
Four months after leaving Earth, Mariner 2 passed Venus by, becoming our first interplanetary traveler.
Mariner 2 was the first successful flyby of anywhere in our solar system, making that journey past Venus for the very first time, looking at that cloud-covered world and getting a sense of the gases in its atmosphere.
Mariner 2 revealed a thick, crushing blanket, almost entirely composed of smothering carbon dioxide.
Venus is an inhospitable place. We wouldn't want to live there.
Sulfuric acid rains down from near hurricane speed winds, except it can't reach the surface because it's so hot.
Despite being a similar size to Earth, we had not found a twin, but a worst-case scenario of a runaway greenhouse, a buildup of heat-trapping gases that spiraled out of control.
Clouds trap heat, increasing levels of carbon dioxide from volcanoes, say. That heat in turn causes greater evaporation, more clouds.
It's now insulated and boiling at this huge temperature.
The accumulation of its thick atmosphere didn't just affect Venus's temperature and pressure. Mariner 2 confirmed that Venus spins on its axis opposite to the conventional direction of the other planets. But that may not always have been so.
We think that in the first couple of billion years after its formation, Venus was rotating in a similar way to the other planets. And then over the last few billion years, Venus has been slowing down, almost stopped, and then actually rotating in the opposite direction.
Venus's thicker atmosphere may be to blame. The Sun's gravitational influence could have pulled on it with enough force to cause the retrograde rotation.
All we know is that there is something very strange in the history of Venus. It has a very strange atmosphere, and perhaps the two are connected.
Hot on the trail of Mariner 2, the Soviets initiated the Venera program. The goal was not merely to pass Venus by, but to touch its surface.
All the while during the Cold War, where the US was aiming for the moon, the USSR was also sending missions to Venus. It's the real red planet, you might argue.
Early probes were crushed by the intense pressure before they even reached the planet's surface.
As the first missions started to go and get closer data, it became clear that Venus had an extremely challenging environment.
The next probe's parachute failed, but it reached the surface intact. Venera 7 made the first transmission from another planet's surface. The probe survived for 23 minutes before succumbing to heat and pressure.
The Venera program run by the USSR was an incredibly successful mission, actually, in terms of scientific exploration of our solar system.
The probe measured surface temperatures of 475 degrees Celsius, and scientists inferred an atmospheric pressure 91 times that of Earth's at sea level. 5 years later, in 1975, Venera 9 returned the first image from the surface of another planet. A single black and white photograph exposing a rather mundane, rocky surface.
It seemed to be an almost impossible task to be able to land probes on a surface of a world like that. But the Russians achieved it and sent back the first images of that world.
And once that mission had been successful, it was possible to design the future missions to adapt to what we now knew those surface conditions were.
The Soviets continued the Venera program into the 1980s, sending back ever more images and data.
Those images, even today, are helping us to form our understanding of that planet, even though we're only just looking at a few small areas.
Rather than focus on one small area of Venus, NASA's next mission sought to map nearly all of its surface. On May 4th, 1989, Magellan became the first deep space probe launched from a shuttle.
The advantages of launching a probe such as Magellan from the shuttle rather than from a conventional rocket are that you have a bit more control over how it sets off.
There are humans operating the shuttle, and they are able to safely check out the instrument before releasing it into space.
That allows you to really efficiently send the probe off without any difficult thrusting maneuvers or anything coming from the spacecraft itself.
We started the elevation procedures for the deploy. We went ahead and threw the switch and sent Magellan on its way.
"4 months after leaving Earth, Magellan began transmitting radar images of the Venusian terrain.
The Magellan spacecraft could use radar to penetrate through that blanket of cloud, to look at a surface that was totally alien. It was a world covered in volcanoes and areas of lava flows.
Mapping of Venus quickly showed that it's also active. Venus is volcanically active, it's seismically active. Processes are happening on the surface. Land is changing, land is forming.
Though some regions demonstrate geologic change and renewal, Venus's crust is hundreds of millions of years older than Earth's. Our neighboring alien world cannot recycle its rock the same way our planet does, through the movement of tectonic plates. Magellan revealed the possibility that within 2 billion years of its early history, Venus may once have been like Earth, with a liquid water ocean and habitable surface temperatures.
We think that Venus originally had an atmosphere similar to Earth, but over time, the water boiled off due to the sun's radiation, because Venus is closer to the sun than the Earth, so it receives more of the sun's light.
As the sun ages, its luminosity grows, shining an ever more powerful light on the Earth. Combined with humanity's addition of greenhouse gases into the atmosphere, our planet may one day reach a similar fate.
Potentially, our Earth could go the same way. So it really makes us think about how precious our environment is.
There is a mystery with the origins of Venus that we want to understand, if only to potentially save ourselves in the future. It really is the evil twin of our Earth, and that was only revealed because of these robotic missions.
The European Space Agency's Venus Express began orbiting the planet in 2006. One of the craft's more surprising discoveries was an uncharacteristically cold region high in the planet's atmosphere, where carbon dioxide could freeze into snow. Dipping to minus 175 degrees Celsius, atmospheric layers like these entice astrobiologists.
The atmosphere of Venus might be home to some kind of life. It's possible. It wouldn't be anything like we think about here.
As a world of so many extremes, a myriad of mysteries remain.
Venus will retain its mysteries for a little longer, I suspect, if only because it hides them so well.
Named for the Roman god of messengers, travelers, and thieves, Mercury is the smallest planet in our solar system. At an average distance of 77 million kilometers from Earth, Mercury is the innermost world.
Mercury is a tiny planet and very close to the sun. And the sun has a constant stream of very hot charged particles coming off it called the solar wind. And that actually stripped away Mercury's atmosphere a very long time ago. And it's actually creating a little helium atmosphere from the gases inside the rocks on the surface of the planet.
Mercury is a world of extreme temperatures, over 400 degrees Celsius during the day and negative 200 at night. Understanding this tiny world is a crucial piece in the puzzle of the terrestrial planets.
The world itself is remarkably dense.
Like Earth, Mercury's interior has layers. However, Mercury's core contains far more of the planet's mass, 85% compared to Earth's 55%.
If you think about what's underneath the ground of the Earth or Venus or Mars, if you strip away the atmosphere and the stuff on it, this is probably the core of what a planet looks like.
It gives us a handle, a way to try to wind the clock back to those earliest days of our solar system, and that's why we're so fascinated by it.
Launched on November 3rd, 1973, Mariner 10 was the last spacecraft of the program, but the first ever probe destined for Mercury.
You've got a means of getting a tremendous amount of information that is beyond our imagination at the present point in time.
The energy costs to sink so deep into the gravitational well of the sun as Mercury resides is more costly than to go the other way to the outer worlds.
There were whole new areas in astrodynamics that had to be invented, to be able to do this kind of thing.
In order to reach Mercury, Mariner 10 was the first spacecraft to employ an interplanetary slingshot maneuver. Flying first by Venus, it used the planet's gravity to decrease the size of its arc around the sun, bending its flight path toward its target.
You have to do your rocket burns at exactly the right time. You have to alter your orbit in exactly the right amount. You have to do course correction, otherwise you can just miss.
An error of only 1 mile at Venus, if not corrected, could result in a 1,000-mile error at Mercury.
Approaching Mercury, Mariner 10 began transmitting photographs of a world pocked with massive craters, revealing more clues to the formation of our solar system.
We think that these massive craters are evidence of early bombardment. So there was a period right after the solar system formed where there was a huge amount of massive asteroids and comets which bombarded the planets.
Mariner 10 was the first spacecraft to return to its target, rendezvousing with Mercury 2 more times.
To be able to fly past the planet not once, twice, 3 times, it actually helped us learn a lot more about this gravitational slingshot maneuver, which is essential to all of the missions that we use today across the solar system. So Mariner 10 was the cornerstone of every single mission that we fly today.
Across its 3 encounters, Mariner 10 returned over 2,700 pictures of Mercury, revealing nearly half the planet's surface. Since March 1975, the spacecraft has slept soundly, still in orbit around the Sun. The next mission to the innermost world would take decades of preparation.
2, 1, and liftoff of Messenger on NASA's mission to Mercury, a planetary enigma in our inner solar system.
After a 7.9 billion kilometer journey lasting 6 years, Messenger entered Mercury's orbit in 2011.
Messenger was the first chance to actually put a spacecraft into long-term orbit around the planet Mercury, to truly map its surface.
The probe had to circle the Sun 15 times before it reached the exact speed and position to be captured by Mercury's gravity.
We got a whole world view of this planet, particularly the polar regions of Mercury, areas where there are craters that have been in shadow for billions of years.
We're seeing all kinds of evidence for volcanism, the tectonic deformation of these plains, ghost craters, which are pre-existing impact craters that were later covered over by lava.
The striking images of the planet's surface helped confirm a theory that Mercury is actually shrinking.
What we're talking about here is a phenomenon in the late stage of the evolution of planets. Planets were very hot in the early history of the solar system, and most of that heat still has a residue in the interior of the planets.
As Mercury's interior cools, shedding the heat generated during its initial formation, the surface is pulled inward, causing the planet to shrink.
The surface is scarred, and we see those cracks and fault lines as the ground beneath the crust shrinks. This is a bizarre world, and one that is very much worthy of our attention.
Messenger's mission came to a dramatic end in 2015.
We'd like to end a mission in the most useful scientific way.
When the Messenger spacecraft ran out of fuel, it was sent on a final experiment, and that experiment was to basically self-immolate on the surface of Mercury.
While we could study Mercury from orbit and we could make some educated guesses about the density of the surface, best way to do that is to smash your spacecraft into it.
Closing in on the Mercurian surface, Messenger was able to collect data on the magnetic anomalies in the crust and ice hiding in the shadowed craters near the planet's poles. Mercury will not be alone for long. Launched in 2018, The joint European-Japanese mission, Bepi Colombo, has been spiraling toward the innermost planet.
The missions are designed to be as wide open in terms of their capabilities as possible because we simply don't know the right questions to be asking of worlds that are as unknown as Mercury and Venus. That's what makes the exploration fun.
Mars, a world half Earth size, hangs as a red speck in our night sky. The outermost terrestrial planet, Mars's orbit lies 78 million kilometers beyond Earth's. As telescope technology improved in the 19th century, observers began to record fascinating shapes on the Martian surface. The sketches of Italian astronomer Giovanni Schiaparelli hinted at extraterrestrial architects.
In the late 1800s, Schiaparelli made observations of Mars and drew maps of its surface. And some of the features that he saw, he labelled canali, meaning channels in Italian.
This created great excitement that we might actually have neighbours, you know. We might go to Mars and there would be other beings that we could talk to.
In the 1960s, probes to the red planet sought to separate fact from science fiction. The fourth probe of the Mariner program became Mars's first visitor. Over a few hours, Mariner 4 captured 21 complete images and a partial 22nd. But each would take nearly 9 hours to transmit back to Earth.
Hey, there she goes. Yeah. That's data.
They had to wait so long for such a small amount of data.
The figures cascade to the Earth. 240,000 bits of binary code, representing 40,000 dots that will finally make up the first picture.
They're waiting so long that they, in fact, started to color in the pictures with pastels because to actually process that data would take even longer and they just couldn't wait.
The images did not reveal a world of extraterrestrial canals.
When Mariner 4 gave us the flyby images of Mars, it revealed a desolate landscape.
They saw dry rocks and craters and dust, and this is not at all what they expected.
And I think that may have been disappointing to the community at the time. We took for granted that the variation we see on the Earth would be found elsewhere, not realizing how unique water, and in particular life, is.
However, Mariner 4's pictures were snapped in a momentary flyby. A prolonged trip to Mars might reveal more. The penultimate Mariner mission would confirm whether or not Mars was truly uninhabitable. The Mariner 9 probe launched in May 1971.
Mariner's rocket engine will be fired for 15 minutes, slowing it by 3,500 miles per hour so it can go into orbit.
Mariner 9 became the first spacecraft to orbit another planet. The probe's instruments began to unveil the planet we know today.
In nearly a year of operation, 2 television cameras transmit more than 7,000 photographs to ensure that the entire Martian surface will be mapped.
An extraordinary world. 2 halves, the northern hemisphere almost perfectly flat, southern hemisphere heavily cratered, pockmarked highland regions, mountains, and sort of in between them is this anomaly, what we call the Tharsis Rise. It is an area where there was clearly huge amounts of volcanism in Mars's early history.
An enormous rift valley, almost 3,000 miles long. An astounding feature which no one expected on Mars.
Mars has the highest mountain in the solar system, Olympus Mons, a giant volcano. It has dust storms, it has weather in its thin atmosphere, so it really is a very active world.
We have fossilized riverbeds. There are mineral deposits that could only have formed in seas and lakes. We have features that reveal global oceans. Mars has revealed itself to be a world with a past, at least, that was water-rich.
Mariner 9 provided the first clues that waters once flowed on Mars. Humanity's first close-up examination of Mars would be facilitated by two identical craft, the Viking landers.
They were designed to learn as much as we could about the surface of Mars, given the technology that was available.
A small shovel on the end of a telescoping arm will scoop up some Martian soil, then drop it into a chemical analyzer on the Viking landing craft.
Vikings 1 and 2 would touch down on opposite sides of the globe.
The first photo from the Viking mission was actually of the lander's foot. That's a really interesting first image to see because it gives you scientific information as well about what the surface is like.
Look at the beautiful rock. Fantastic.
In addition to collecting photographs and measurements of the surface, the Viking landers dedicated 3 experiments toward the search for life.
The Viking spacecraft were looking to see whether there was any evidence, for example, of methanogenic microbes on Mars, microbes that would emit methane.
Were there Martians? Was there some kind of life somewhere at the surface or below the surface of that world?
Scientists concluded that the makeup of Mars's soil, coupled with solar ultraviolet radiation, restricted the formation of living organisms. But Viking's findings didn't exclude the possibility that an ancient Mars once supported life.
So we don't know really where we are in the evolutionary cycle, and of course that's part of what we're trying to find out.
With the Viking missions in the 70s, they were simple landers sitting down on 2 different spots. But if you really want to explore, you need that mobility. So we had small little rover called Sojourner, which landed with the Pathfinder mission in 1997. It showed that we could operate a small automated vehicle on the surface of Mars, but again, it couldn't go very far afield. So they decided to build 2 rovers with the lander and the rover as one vehicle.
The Mars Exploration Rovers were twin solar-powered robots designed to hunt for evidence that ancient Mars once held water.
They were equipped with an entire laboratory to measure the mineral content and other properties of samples that they were able to collect.
It was just transformative with having that ability to be able to just have an automated human being going around the planet.
Getting a bounce signal. We're getting a bounce signal. They're getting a bounce.
Spirit landed in a crater which certainly showed signs of being once filled with water, but sometime in the intervening history of Mars had been covered over by a layer of lava. So Spirit had to go on a much longer journey, traveling several kilometers to reach some mountains. And literally, the moment they got out of the lava field, they found what they coined the pot of gold. Evidence that there was water in this spot billions of years ago.
Spirit found rocks rich in iron and magnesium, which could only form when Mars was wet and warm. Spirit's twin successfully landed on the other side of the planet.
The Opportunity rover, she landed in a small crater, the ultimate hole-in-one. And right in front of that rover was direct evidence that there was sedimentary layered rock, materials that can only form in the presence of long-standing water.
The puzzle pieces have been falling into place. We have concluded that the rocks here were once soaked in liquid water.
Spirit, she had to struggle for everything to achieve the goal of finding out the water history of Mars. For Opportunity, it was all laid out in front of her.
Originally slated for a 90-day mission, Spirit lasted over 6 years. Opportunity kept going for another 9 after that, traveling a total of 45 kilometers, further than any off-world rover.
Opportunity made us Martians. There's been a team of people that go to work operating the rover, and the surface of Mars has now become our neighborhood.
Mars can be both cruel and kind. They thought dust building up on the solar panels would eventually block the sunlight, and that would be the end of their mission. But those whirlwinds on Mars blew the dust away, kept the solar panels clean, allowed the rovers to drive further, to continue doing more science.
However, in 2018, a planet-wide dust storm sealed Opportunity's fate.
This dust storm, it was really sad. It actually was so huge it covered the entire planet. And then it lasted so long that Opportunity didn't have any power left.
The rest of the instruments were working fine, but if you don't have power, you can't do much else.
The last message from rover Opportunity was a message from the engineering instruments on board. And effectively it was, my battery is getting low and it's getting dark. And 15 years of operations on the surface of the Red Planet finally came to an end.
This concludes operations for MER-1 spacecraft ID 253.
Sad day for all of us.
MER project off the net.
Even without our rovers, humanity still had a close eye on the Red Planet. NASA designed the Mars Reconnaissance Orbiter, or MRO, as a next-generation eye in the sky, capturing surface features as small as a meter. It carried a novel telecommunication system that other Martian missions could use for a navigational aid. Since its arrival in March 2006, the MRO has circled the planet more than 60,000 times and sent back more data than all Mars missions combined. Its powerful camera has mapped 99% of the surface in unprecedented detail, revealing a planet that is still active and changing.
The reason we know a lot about Earth is our satellites. We can measure what happens as a planet as a whole, how it changes over time. And that's what Mars Reconnaissance Orbiter has been doing for Mars. It's been measuring changes over the planet as a whole.
Having a vehicle orbiting around Mars like the Mars Reconnaissance Orbiter with its high-resolution cameras has revealed the planet as an entire world with a diverse geology. And in some ways, it's actually got better maps of the planet Mars than we currently have for the Earth.
The MRO identified places of interest to send future landers and rovers, continuing the hunt for Martian water.
While there was very clear evidence of there being water once on the surface of Mars, we'd never really had a chance to get down there and dig it up and taste it with the instruments of a spacecraft. The Phoenix mission was landed near the northern polar regions of the Red Planet and had a digger on board.
Touchdown signal detected.
And just 6 centimeters below the surface, it came across this bright white material.
The rovers have been investigating the history of past water on the planet Mars for almost 5 years now. Phoenix is the first mission to actually touch that Martian water.
We tasted for the very first time the waters of Mars.
Water is fundamental to human life. Knowing where the water on Mars is, how much there is, and how to access it is critically important for any potential future missions.
While water is an essential ingredient to life as we know it, our robotic Martian spies have detected a chemical often created by life: methane.
The probes that we've sent there have not yet found definitive evidence of life, but there have been some close calls. There have been some signals that potentially complex organic chemicals might be there.
We have tantalizing hints of methane on Mars, and why that's important is, at least on Earth, methane is produced by living organisms. We call it a biosignature. It's entirely possible this could be geological in origin, but we may have found those first clues of life itself beyond the Earth.
The hunt for life and other mysteries Mars still holds will continue with future missions.
Where did the water go? Did it support life? Could it support life? Mars is a great example of all these big questions we have about the universe on our doorstep. And because it's on our doorstep, we can explore it more. And as we explore it more, like everything good in science, more questions arise.
We continue to probe Mars's past, hoping to understand its transformation from a primordial watery world. Our star bears some of that responsibility. In order to comprehend the mechanics of the inner planets, we need to unlock the secrets that drive the solar system. We need to study the sun.
The sun creates all the heat and light in the solar system that enables all life on Earth to exist. It's also created very extreme environments in the other terrestrial planets.
Prevented life in Mercury by stripping away its atmosphere. It prevented life on Venus by causing the evaporation of all the water and turning it into a runaway greenhouse.
Our sun produces its own weather, matter and light streaming out, influencing every orbiting body to some degree. Every so often, intense flares rise above the surface, ejecting charged particles up to 3 million meters per second. Sometimes these ejections collide with the Earth.
When you see those beautiful aurora, the northern lights or the southern lights, that is caused by solar storms, stuff leaving the sun, hitting our Earth's magnetic field, rubbing it around. Now that's great, pretty pictures, but it also creates radio interference. It creates problems here on Earth.
The surge creates a geomagnetic storm, which heats up portions of the atmosphere and applies drag to satellites. It interferes with navigational systems and induces harmful electric currents in power grids.
So if we want to predict that solar weather, we need to understand how it originates, and we have to get up close and personal with it.
Space-based missions have been trained on the sun for decades. But until recently, they've all kept their distance.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
Launched in 2018, the Parker Solar Probe will arrive within 6.2 million kilometers of the Sun's photosphere, what we describe as the surface.
The Parker Solar Probe is ambitious because it's going to get just so close to the sun. And as you can imagine, that's going to be quite a hot place to be. And also, there's going to be a lot of radiation from the solar wind as well.
Beyond the Earth's magnetic field, which directs most of the solar wind away from us, the Parker Solar Probe's instruments will have a shield of their own. 2 plates of carbon encasing a core of carbon foam. On one side, temperatures will reach up to 1,400 degrees Celsius. But behind the shield, the bulk of the spacecraft will rest at a comfortable 30 degrees.
The ability of that spacecraft to survive the journey, for its instrumentation to work, and to deal with that input of thermal energy from the front side, from the sun, it is quite astonishing.
The sun's temperature is one of the peculiar puzzles we seek to solve.
There's a big mystery. You go to the sun, the surface is 6,000 degrees Celsius. Move away, the temperature doesn't go down as you might expect. The temperature goes up, and it goes up dramatically to 2 million degrees Celsius. How the sun is actually doing that, we've got lots of theories, but the Parker Solar Probe will help us test those theories.
It's really important for us to gain a greater understanding of the solar activity and to monitor it. It'd be great if we could model it.
The sun is the engine of our solar system. The Parker Solar Probe is going to help us understand a lot more about that engine, how it actually works. We'll get to lift the hood of the vehicle for the first time.
Humanity has long aspired to become a star-faring species, and the terrestrial planets may one day open a gateway to the universe. Mars is the closest within reach, but the challenges are many.
While it takes a few days to get to the moon, Mars is a completely different kettle of fish.
A one-way trip to Mars would be roughly half a year, but a mission that brought humans back home would last 2 years.
The biggest hurdle to start with is how do we get people to Mars, never mind getting them on the surface.
Those technical challenges are certainly huge, that's for sure, but we have a pretty good history of overcoming that sort of thing. The biggest challenges are going to be the human challenges.
Getting there emotionally healthy, physically healthy, that will be a major stepping stone.
The communication delays would be considerable. The delays in getting medical help would be considerable. So those colonies would have to be very much self-sufficient.
Crewed exploration will require well-planned infrastructure already in place.
We need to be thinking about self-sustainable missions and the utilization of resources in situ, things like fuels, water from the planet, and using those to create the things that we need to survive.
It turns out that Mars is not an easy place for humans to live on.
If we were living on Mars, we'd actually have to live underground, because in addition to the massive storms that exist and the cold temperatures, there is no ozone layer. The sun's rays come straight in, and that would cause cancers and other terrible problems in humans.
It has all kinds of hazards to do with radiation, as well as the fact that its atmospheric pressure is only about 1% of the Earth's. Its temperature is very low. It would not be an easy place for humans to make a home.
Laying the first boot prints on Mars will require our brightest minds.
There's some amazing innovation that needs to be done by solving this for things like the lunar mission. There's all this translatable devices and technology and know-how that benefits us back on Earth. We always get benefits by doing this kind of new innovation and not being scared by these big challenges.
Before we set foot beyond our Earth, we must answer a fundamental question. Are these worlds meant for us?
I think it's a fantastic philosophical discussion right now. We can colonize Mars at some point in the future. Whether we should or how do we do that appropriately?
I believe that humanity has the duty to explore. And with that comes a duty of care to the places that we travel.
For all we know, Mars might actually have living organisms on it. Until we could say with certainty that Mars was completely sterile, we need to be very careful how we treat Mars and not just look at it as a place where humans can take over.
We should step lightly. The moment we step foot on an alien world, we have forever changed it.
Unlocking the secrets of the inner planets, humankind learns more about our home.
We look at Mars and we look at Venus, our neighbors. In a lot of ways, they are very similar to different times of the Earth. And that will give us clues onto our own history and our own destination.
Though the past century of exploration has revealed much, we must continue pushing the boundaries.
Explorers is who we are as human beings. We all do it from the moment we're born to the moment we die. Without exploration, we don't advance as a civilization.
The question is not if we will venture to these worlds, but when.
It's in our nature to explore and to understand and to investigate and to be inspired by doing so.